so let's do that substitution first. So we're going to get the integral of half outside of 1 minus cos 2x. Joel, what do we want to do when we had something like this? What's a strategy we can do to make it a little bit easier? Yeah, take the half out. Doesn't really affect you. Okay. And then, well, we've got a very similar thing over here, so we can use our rules of integration. Just be careful. Yeah, you've got a negative cos 2x here, so that's going to be negative half sine 2x. And then plus your constant. And there's your result. Similar idea, we don't want to memorize this. You can memorize this substitution, that's fine. But we want to make sure we're doing those very clearly. All right, Joel, lighten us to the mood. Can you walk us through?
3.
Yeah, let's do 3.
So you do first chuck in the substitution.
Yeah, let's do it.
But
what?
3 is still staying out.
But wait, there's more. Okay, so what are we going to do?
So you make it so it's half outside of 1 minus cos 2x.
Yep.
D of dx.
Yeah, awesome.
And then you do half times 3 outside of the integral. So you get 3 on 2. And then you 1 minus cos 2x dx. And then you just integrate it.
And then you have the same kind of formula. So often, like, you can just pull constants out, and then you'll get like a similar result anyway. So we get 3 over 2, and then we've already got this over here. We've got x minus half sine 2x plus any constant values, right? One thing I will kind of mention is that you'll notice that, like, hey, the 3 on 2 should be outside the whole thing. How come we're not multiplying by the constant as well? We'll often kind of do this because if you do 3 on 2 multiplied by a constant, well, what's that going to be? That's just going to be another constant, right? So there's no real point to actually doing that. That's just like a convention to skip. So that kind of pops up here and there with integration, like indefinite integrals. All right, next one for me. Callum, you know we go? What do we have to do with this guy? What's our first substitution we could use?
One is just to get cos squared.
Yeah, so what would that be?
So half 1 plus cos 2.
Easy, okay. Now at this point, you can do a few things. Do we want to pull the half out, or do we want to keep it there? What are you guys thinking? You can't pull it out because of this guy here, right? So what did you do, Matt? Okay.
I'm doing it. I was just doing
Okay, well, let's try now. What would you do next?
what would I do next? Let's see. Maybe just integrate.
Yeah, how would we do that? How would we do it?
Alright, we go for
Just do it.
let's just do it like normal. But it looks confusing. I think like expanding it out isn't like a problem either.
Yeah, it's fine. In fact, a lot of the textbooks will have this expanded out as an identity. So you want to do that?
It looks a bit nice.
Yeah? And actually, when you expand it out, what do you notice?
Well, then you can do half.
Then you can group like terms, right? Then you can be like, hey, half minus 1, that's just negative half. But in fact, there is something now that you can factorize out. You can take it, well, negative half, you take out half.
I mean, you could have taken that.
Yeah, you could have taken out here and then just like taken half of that. You can, yeah. Don't make it more confusing. All right, so what do we got? So integrate now?
Yeah.
All right, let's take out the factor first, I didn't do that. The integral of, so we got negative 1 plus cos 2x.
You would have said
Yeah, we just didn't finish it off.
We just went the normal way.
So whichever way you find easiest, right? And then we can do it as per normal. So we're going to get negative x plus half sine 2x plus any constants. So at this point, it's not too difficult if they add other constants in, but I said that there's a generalized form, and here it is. We can write this as sine squared nx equals to half outside of 1 minus cos 2 nx, and cos squared nx equals to half outside of 1 plus cos 2 nx. So the idea with this is, all you're doing is that each time you're using this identity, we keep these constants the same, but the only difference is you're doubling the angle in your kind of new single powered expression.